right, thank you. My job today is to make everybody who's out there who hasn't heard about this topic really nervous and uncomfortable because this is really a nasty bit of work out here. Okay, if anybody was in my talk yesterday, you heard me talk about Phytoptthora cinnamomum on Archistaphylos vertifolia, the Ione manzanita. And this is just a devastating disease. This is an introduced Phytophthora. All these Phytophthora I'm going to talk about are exotic pathogens that have been introduced. And this is basically devastating to Archistaphylos across the board, as well as other species. And these habitats that are affected, it causes 100% mortality as it works its way through there. It works its way slowly uphill, and it doesn't go away. It sticks around the soil, so you have no regeneration over time. Where areas like this, where there's been a lot of vehicular spread, pretty much the plant's been eliminated from those areas on this day. And while we thought that this was kind of an isolated incident in terms of this manzanita combination, it was really the first wildland documentation of a group rotting Phytophthora in California. It turns out it's not the only case. Shortly after, we were asked to look at some Archistaphylos pallida, another endangered species in the Oakland Hills. We found a mortality center in this area. It was also associated with P. cinnamomum a couple of years later. That's just above the Huckleberry Preserve. A couple of years later, we got a call and confirmed that a disjunct population, they also had contamination there, so they were losing plants there as well. Now, we've actually been looking at sudden oak death since 2000, and one of our study sites has been China Camp State Park in Marin County. And there have been non-sudden oak death and mortality of other species there, which hadn't really paid a lot of attention to because we were so busy with sudden oak death. But one of the things that occurred to us at some point was that even though the oaks in this area, this canopy gap is due to the mortality of oaks due to sudden oak death, you think these bays would be loving it because they got less competition. The bays are dying. And the reason the bays are dying is because of Phytoptthora cinnamomum in the soil. So we had this nice combination of P. remorum killing the oaks and then P. cinnamomum killing the other canopy species. So there's really no native site canopy species that can survive in that area. Well, that particular area is right here. Phytophthora tend to move well downhill, these soil-borne ones, because they can move with cold water. Unfortunately, there's also a spot up here that was detected later. That means this whole watershed down here is potentially going to suffer a similar fate. We've been working with PUC on a number of sudden oak death projects, and they've alerted us to this mortality of madrone in one site. And that turned out also to be P. cinnamomum. It had the same kind of signature. Whoa, okay. Are we still live? Okay. Is Mike dead, or am I going to speak up? Okay, good. Okay, so that signature, the madrones are more susceptible than the bays. So what you usually see is dead madrones and dying bays when you first hit these centers. On the MMWD property, Mount Tam watershed, we've also seen P. cinnamomum killing madrones in that area. There's some affected spots. As you may have mentioned on the earlier site with the pallida, there was chinkapin, it was giant chinkapin that was dying. And we were checking into some mortality. This is also in the Mount Tam watershed, and found a large mortality center of giant chinkapin, as well as a lot of other things looking rather poorly in that same mortality center, again, Phytoptthora cinnamomum. One of our most recent finds, Jack London State Park, where we had both Phytoptthora cinnamomum and Phytoptthora cambivora affecting bays, madrones, some other species as well in this area. So that's just another recent find in an area that has gotten a certain amount of use. And we can go elsewhere. This was actually in the Yakima Mountains, a couple of different Archistaphylos species. Phytoptthora cambivora was associated with a number of spots of mortality associated with potentially digging activity in these sites where they're doing a percolation test. Here's a Phytoptthora taxon. It doesn't actually have a name yet. It's called Phytoptthora PG chlamydo. This was associated with mortality of coffeeberry and young coast live oaks on the PUC watershed. And this site where we had a failing Doug fir plantation on watershed Ecryptogea was found associated with these trees. So what I want to give you the first bit here is that exotic Phytophthora species are out there now killing native vegetation. It's not something theoretical. It's something that's happening, and these are places we happen to gone and documented it. There are probably a lot more out there. And what we don't want to see is more and more of them. Well, how do these Phytophthoras get into these areas? Well, here's an example of one where you can probably make a pretty obvious connection between the landscaping around this home site. Nursery container stock, the commercial nursery stock, is well known to have a lot of Phytophthora associated with it, so that was undoubtedly introduced into the soil in that way. Another example of that is the Phytoptthora state. This goes in the middle of a Pythiaceae watershed. All these spots here are different Phytophthora species shown here from samples. There's a big, that Madrone Mortality Center is that area. These spots here are a connection between the caretaker's house and the gardens there, including a nursery, and they traverse back and forth on those roads. The contamination spread there and up and down this road that's used for service, old Kenyatta Road. So we've known for a long time that native plants, our nurseries, are just problems for Phytophthora. A few years back when we had to do the actual pathogenicity testing to show that Madrone was being killed by Pythiaceae, Elizabeth Fitchner from the Rizzo lab did some pathogenicity tests, and she had to repeat them a couple of times. She did them first on these kind of scabby-looking plants, so she had to buy some plants so she could test them. Well, the problem is that most of the plants you got from these native plant nurseries were already contaminated with, among the other things, the same species that we were trying to test. So that gave us the first inkling that, well, yeah, these native plant nurseries are probably no cleaner than other commercial nurseries, which is not surprising. So for a long time, actually, since we've been involved in oak restoration, from the beginning, we've always talked about planting acorns. This is an acorn, direct-seeded, no irrigation restoration planting in Vacaville. And that is something that we've always cautioned as an issue, is that we don't really want to be introducing pathogens in the process. And if anybody saw Janelle's talk today, I didn't actually see it, but she talked a little about this particular project. The bottom line is that if we're introducing exotic pathogens, that's not restoration, that's degradation. And we really hit the fan with it on this work we were doing with PUC. They have a large bioregional habitat restoration project. Ellen Natason talked about it yesterday. It's a big ticket item. We actually went to some of the nurseries that were going to produce plants for them and tried to see what their practices were, tried to see if we can get them to upgrade them to produce a little, increase their chances of producing cleaner material. There's problems with this site. If you don't see them, then you need to come to another talk because we'll talk about that. But the bottom line is, amongst material that was planted after these people were basically forewarned, among other things, the first sample we got was this quarantined Phytoptthora tentaculata, which happens to have only been found once before in California in a native plant nursery. And this was the second detection on a new host, Toyon. It was only found on Mimulus ranthiacus before. And that looked a lot like the plants in the nursery. Actually, these plants had both Cactorum and Tentaculata. Because that was a regulatory thing, it set up a lot of extra sampling. We went to some of the other nurseries that they hadn't planted material from. We saw a lot of plants that looked very suspicious. And in this particular site, we should have probably got Phytophthora out of all these, but this particular nursery is using a fungicidal chemical, which actually makes it a little difficult to detect it. What they and a lot of other people don't understand is that these fungicides only suppress the pathogen, they do not kill it. So that means it's still in the soil. And in fact, in some of the oaks, we picked up Phytoptthora quercitorum, which is another unusual species that isn't documented in California to any considerable extent. Carex, barberry, we went to another nursery, there was this carex there, we thought, well, that might be a host of Phytophthora. But we're here, so we'll take some samples. Well, what happened? We got Phytophthora under. So either the soil was so heavily contaminated that it was in there, or this is a host that we just don't even know. Another site, a lot of the other sites, material had already been planted, there was nothing left in the nursery. These torions were sampled out, they were still in their little mesh planting bags, partly because the roots were rotten when they weren't growing out, because they were all Phytophthora captorum throughout those plantings. Phytophthoras are water molds, and wet situations favor their spread. So this kind of site is one that's kind of a nightmare scenario. So we were sampling in here, we found 2 species, including Donna, another unusual species, only documented once in California before that we know of, in amongst these plants. And even more so in the areas where plant materials were spread, and we had people going in and out and whatnot. We actually were able to pick Pythiaceae up out of the water itself here. So that means there's been wider contamination of the site. The PUC at San Antonio Creek site, we resampled a number of times to try to get a handle on how big the spread was. One of the interesting things here from a plant pathology standpoint is these are 2-year-old Mimulus, and they had Pythiaceae, and that means it was introduced at least a year earlier, and it was able to survive for the entire year, over summer, over winter. The plants, a lot of them looked pretty good the first year, started to collapse the second year. Another site where Mimulus was carried over a year, in this case Megasperma and Pythiaceae. On that, I think we're starting to get a theme here down. We started looking, actually we're not too far from this particular site, the Guadalupe River. We took some samples here because we were interested in seeing whether we could pick up some Tentaculata. Along the way we picked up some Cactorum on this coffee berry that had been planted. And instead of Tentaculata, we picked up Niederhauseri. Niederhauseri was just described, given its species name in 2014 in Mimulus. And again, Janelle talked a little bit about her project this morning. I don't know who went to that and how well she covered this, but in that particular planting, and assisted migration planting, all the material is infested with P. cactorum. So dying, and it needs to be eradicated if we hope to save that site for future use. This is one of the methods used to detect Phytophthora with green pairs. You get lesions on these pairs with Phytophthora. This is from those Ceanopus plants. They're very heavily contaminated from the extent of browning you can see on these pairs. So here's a brief summary. This isn't everything. This is just some of the stuff that we've been working with. What you see here is a list of a variety of plant species. Blue ones are things that are monocots that we generally don't think of as even being susceptible. The red ones along this path are things that are either rare or first-time descriptions in California, so they're new introductions. The field samples are the green, nurseries in blue. Bottom line, as you can see, we've got a lot of junk. We've got a dirty dozen up there right now, but we could go on further and probably find more. Can't keep score without the box score, so we get nurseries here. I actually see the number of pathogens in some of these that we recovered higher than the number of hosts that we actually sampled. And some of these have vast arrays of Phytopthoras. So why should we be concerned about Phytopthoras in nursery plantings? If you try to get an idea here. Contaminated nursery stock, if I wanted to infest an area, what would be the easiest way to do it? Let's find a lot of infested material. There's an increasingly wide variety of Phytophthora species showing up in nurseries. This is data from a recent study where nurseries were followed for an entire year. In 4 Oregon nurseries, 28 different taxa of Phytophthora found over the course of the year. In the long version of this talk, I'll go over this thing in some detail, but all the factors that affect disease progression are optimized in nurseries, basically, for Phytophthora. Nurseries are just about the optimum environment for encouraging Phytophthora. We've already seen, as I began to talk, that Phytophthora species are already showing up in wildland areas, causing destruction of habitat. We've got both rare and common species that are affected. Once these things get into the landscape, into wildlands, they get moved around by people's shoes, by equipment. Here's an eucalyptus removal operation, a very good way to move lots of soil from a contaminated area. We, as I mentioned, Phytoptthora moves preferentially downhill with flowing water, so we put in a restoration project at the top of the hill. It's going down to the bottom. And these are very persistent. This is actually regeneration of biomagneta that's been killed, and because of the residual propagules in the soil. As we get larger and larger areas, like these ones at Jack London, you can't really eradicate in those areas. It's just not, all you can do is try to manage for it. So there's a wide variety of reasons we should be concerned. These are already serious pathogens in other parts of the world. Australia has got actually much worse problems than we have with peace and loaming. They've been identified as international global issues in the plant trade in general. It's just devastating impacts. And the bottom line is what we're trying to do is spread the word and not spread Phytoptthora. We had an excellent meeting at the Presidio about a month ago, and CNPS chapter here locally videoed it, and those talks are up on that, and if you're interested, there's more to be seen there. This is not a new problem, and what it is a lack of awareness, not a lack of available information. We have nursery VMPs being talked about for additional versions in 1957. Everything in here is pretty much the same stuff. So it's not like we haven't known about these things. This is the bottom line. Start clean, keep it clean. That's simple. Let's leave with these last couple of, these are recent samples I just took. 3 species of Phytophthora on 2 plants. And we didn't sample all the other ones around them. It's really an appalling state of affairs, and it's not something that, if we want to protect California's flora, that's really tolerable. So this is really one of those talks that is hopefully make you feel a little uneasy, and that's going to